My strategy is to split the information up into a vertical section and a horizontal section. Starting by taking that initial velocity and resolving that into components. So the initial velocity is 22 meters per second, 36 degrees above the horizontal. So if I draw an arrow at approximately 22 degrees, 36 degrees, label the hypotenuse here as 22 meters per second. What I'm going to find out are the horizontal component as well as the vertical component of this velocity using this 36-degree angle. So the horizontal component will be done by the adjacent side, so the cosine. 22 cosine 36 degrees. And then the opposite side, opposite to 36 degrees, would be used, we would be using sine. 22 sine 36 degrees. So let me go ahead and get those in the calculator. So I'm getting 17.798. So I'll say 17.8 for the horizontal component. Trying to keep a couple of extra digits here, and I'll just underline the 2 sig figs that it's supposed to be. And now the other one, I'm getting 12.93. So keep a couple extra digits, underline the 2 that it's supposed to be. So those two components of the velocity, I'm going to go ahead and record those underneath my headings there. So the vertical one, I'm going to write V1. So my starting vertical velocity is 12.93 meters per second up. And my horizontal velocity, V, equals 17.8 meters per second. And I'm not going to use a subscript of V1 for horizontal because for horizontal motion in projectile motion, the velocity is constant. That number is not going to change. So I don't need any subscripts there. Okay, continuing to fill out these columns here, the question tells me that the ball is going to land 4.9 meters lower, keyword lower, than where the ball began. So that is going to be a vertical piece of information, and that relates to the displacement. So vertically, the displacement is 4.9 meters down. I'm going to write it as negative 4.9 meters up because I already wrote my velocity as up, so I want everything to have the same direction. And one more thing that you can always add to the vertical list for projectile motion is the acceleration, which is due to gravity. And that's, I'm going to use negative 9.8 meters per second squared up. Okay, I believe that is all the given information. So what I'm supposed to find is the horizontal displacement here. And that's the question. What's the horizontal displacement? So that goes over on the horizontal column. And how do I find that out? I'm not given much on that side. I'm only given the velocity horizontally, and That's by itself is not enough to know the displacement horizontally. Velocity is how fast it's going horizontally. So if I can figure out how long it's going that fast, then I can figure out the horizontal displacement. So really what I need to do is figure out time. And I'm going to figure out the time using my vertical information. And once I figure that out, I will transfer it to the horizontal information because the time is going to be the same for both sides. It's the same experiment happening at the same time, horizontally and vertically. Okay, so I can calculate this time using the big five formulas. So the one that is going to apply will be the third one. And to solve for time, it turns out I'll probably have to use a quadratic formula here. So I'm going to go ahead and fill in the numbers. Don't usually like doing this so soon, but when we gotta do the quadratic formula, I don't really see much other way around it. Okay, to use the quadratic formula, I first need to get everything on one side and have one side 0. So I'm actually going to move everything to the left side and get the right side to 0. That's because I'm looking at my t squared term. And right now the coefficient of my t squared term is going to be half times negative 9.8, which is negative 9.4. But I prefer a positive coefficient for the squared term, so I'm going to move that to the left side of the equation. It'll be positive 4.9 t squared. And then I will move 12.93 delta t over. That'll become negative 12.93 delta t. And I will keep minus 4.9 on the left side. Okay, so now I have one side 0. I can go ahead and use the quadratic formula. You know what? I'm just gonna search up a quadratic calculator on the internet here. Actually, I'll use Wolfram Alpha. wolframalpha.com. That's WOLFRAM alpha, ALPHA.com. And with that, I can just type in 4.9, I'll just use t squared minus 12.93t minus 4.9 equals 0. And Wolfram Alpha it's thinking, it's calculating, it's given me the graph of the parabola actually, that's pretty cool. And it's given me two values for time. One of them is negative, which is going to be inadmissible. And the other one they give us is 2.97, which I'll underline the 2 sig figs there. Okay, the negative time is inadmissible. Okay. So that time can now be transferred over to the horizontal side. So I'll just write 2.97. And now I can carry on and find the displacement. So the horizontal velocity is constant. So we can just use the formula velocity is displacement over time. And isolate for displacement. That will be velocity times time. So I'm multiplying those two numbers together in my list. and that is giving me 53 meters.